Okay, now we're recording. All right, sorry guys, y'all missed up to the first example, but you can catch on now. All right, example 2. Find the coordinates of the image of triangle ABC after a translation where our rule says take the pre-image xy, and we're going to translate it by adding 2 to our x and -1 to our y. Okay, so to find our A prime, B prime, and C prime, what we're going to do to find A prime is we're going to take every value, x value, and add 2 to it. And to get our y's, we're going to take every y value and subtract 1 from it. Yes, ma'am.
So where do we even get these translation numbers that you have?
Where do you get this? The rule?
No, where, like, I understand the rule, but I just don't understand, like, why do you have to add 2 and take away 1? And, like, is that what it's telling you?
That's what this is telling you. This says take each value, x value, and add 2 to it to get your new x value.
Like, I'm saying, are they always going to tell you?
Yes, I have to give you a rule.
Okay.
I will give you a rule.
Oh, so.
Or sometimes I'll do it backwards. I'll give you the 2 sets of points and ask you to come up with a rule.
Wait.
Okay? All right, so
Which will be?
I'm going to keep going because it's all going to go and make sense in just a second. So this gives us -2, 1. This gives us -1, 3. This gives us 1, 0. Okay? Now, I actually, if I'm asked to graph it, I don't even do it that way though. I look at this rule. What does this rule tell me to do? This +2 means take this point and go right 2. This -1 says take it and go down 1. So B to B prime would be right 2, down 1, B prime. Right 2, down 1, C prime. Right 2, down 1, A prime. Okay, now are these points? These points?
Yes.
Yeah, but for me it was easier just to move them on the graph. So it depends on what they've asked you to do. If they actually ask you to list all the points, then you should. You might want to start with a graph and then just write them down. Or you can start with the algebra and then do the graph. It doesn't matter. Yes.
Oh, my question was completely. I'm still really confused though. Is it always going to give you the rule?
Yeah.
Oh, good. Okay.
That's what she just asked.
Okay. Now, I would like you to try number 3. Now, I want everybody to notice there is a new rule in number 3. It is not the same rule. It's a different rule. So go ahead and try number 3 with this image here. You try, and we'll go over it in a second.
I can't even see it. I hope it's like your baby. Complaining about I've been in.
Would you like us to answer number 3?
It says identify the coordinates of the image. So you have to identify the coordinates.
That is the
Take a look. Did you shift it correctly?
Yes.
Okay, so these are my new ordered pairs. I found them by looking at my graph, but you can just plug in the original points into here and get out your image points. Now, did you notice how I didn't really label this? I guess I could say, ooh, image. But it's not named, so we don't have to do the primes when it's not named.
Good.
All right, describe the type and direction of the transformation. Well, this was a translation.
Right 2, down 1.
Good. It was a translation, right 2 units,
Down 3.
down 3. That first example was down 1. That's where you got it from. Okay. All right, now you should be able to do translations. Let's take a look at reflections. All right, I'm going to pick this point right here, 2, 1. And let's see if we can come up with a rule for when we reflect it over the y-axis. What happens to this point, 2, 1, when I reflect it over the y-axis? What does it become?
Negative.
Negative 2, 1. Negative 2, 1. So what happened? What changed? The
X.
x changed to the opposite. So a reflection over the y just switches the x to the opposite. Negative x.
That's hard to remember.
Well, then do a little point like I did
Wow.
and see what happens. Okay, when we reflect this point 2, 1 over the x-axis, what do I get? To negative 1, which means a negative y.
Oh, yeah.
So it's x negative y. Does that make sense?
That's so hard to remember.
Okay. That doesn't make sense?
That was a
All right,
beautiful
let's write it down
example.
so we can see it. We went from the point 2, positive 1, to the point 2, negative 1. Did this change? Nope, stays the same. Did this change?
Yeah.
Yep, switch to the opposite.
Oh, my finger looks so bad.
Okay, now let's reflect this over this line. So it goes to right here. So 2, 1 went to 1, 2. So what happened? It switched. The x and y switched.
Wait, so when it says y equals x, that's just going to be a line drawn through the order?
That's what y equals x is. You're not going to draw it yet.
Oh, I don't remember that one.
It's like y equals 1x plus
Excuse me. Thank you.
Yeah.
Okay. So,
It was right.
so if we have something other than these, you may just want to sketch in the line, and then you'll go the equal distance on the other side of the line. So if it was like y equals 2, you would draw in a line, a horizontal line, where y is 2, and just go the opposite distance. If your point was up 2, then your reflected point would be down 2. All right. Example 4, pre-image triangle ABC with vertices 1, 4, 5, 1, and 1, 1. Find the coordinates of the vertices of the image after reflection over the y-axis. So y-axis is going to change what?
the X.
Change the axis. So A prime would be negative 1, 4. B prime would be negative 5, 1.
Negative 1, 1.
And C prime would be negative 1, 1.
So smart.
Okay, and then it asks us to graph both of them so we can verify. So this was A, this was C. B prime? No. This is C prime. This is A prime. Are you okay?
You know.
No.
No, that was off. I mean, it's you. Yeah, I sneezed.
And this is B prime.
It's very weird.
So it looks like it's been reflected over the y-axis.
I'd say so.
Yes, ma'am.
Won't it only reflect if it's a negative?
When we reflect it, what it does is it takes all the signs and switches them to the opposite. So if they started off positive, they become negative. If they started off negative, then the x values would become positive. And we could have a mixture. We could have some that were positive and some that were negative, but they all switched to opposite. So that's what happens when we reflect it over the y-axis. Does it look like if I folded this down the y-axis as two triangles that fall on top of each other?
Perfect. Perfecto. Oh, wow,
Okay.
it's only...
Now, this one's a little different, but I still think you can do it. This says quadrilateral, the pre-image quadrilateral map with vertices -2, 7, 2, 7, 3, 5, and -2, 5. Find the coordinates of the vertices of the image after a reflection about y equals 4. So the first thing you're going to do is kind of draw on a line at y equals 4, because this is what I'm going to reflect it over. Right there. Y equals 4. Okay, so we're going to plot these points. -2, 7, 2, 7, 3, 5, and -2, 5. So there's my little map, quadrilateral. And
And negative what, 5?
2. It's on your
It's up
paper.
there. It's on the paper.
You're on the paper.
Excuse me?
Now this is 1 up unit, up 1 unit. H is up 1 unit, so to do H prime, just go down 1 unit. Got it? From your line of reflection.
Oh.
That's all. That's all there is to
I'll
it.
write brown.
Okay, finish that one up.
What do you call the what?
Bye-bye.
Ah,
All right.
I'm so confused.
What's wrong?
I'm confused.
How?
It's just like reflection,
Why-
except it's not over an axis. It's over. I know, that's what I'm confused about. It's y equals 4, so I'm not
Okay,
sure.
so we can't just take the opposite of the thing. What we have to do is, this point is up 1 line. So
So
the
you just,
reflection would be down
oh,
1
so
line.
there's no.
I know
This
you're
point
talking
is up 1, 2, 4. So there's no Oh, there's 2.
And it's yours, man. It's yours. Crap. It's your like.
Okay, are we okay? Is there anybody else that has questions?
This stuff is too simple.
Yeah, you.
This tough stuff gets so easy and complicated, isn't it? Yeah, you were. All right. So now let's investigate rotations. We've done transients, we've done reflections. Let's take a look at rotations. All right. So if we looked at this figure and we know we're rotating it around the origin, we're always going to be rotating it around the origin unless another point is specified. All right, so what type of transformation was this? Oh, well, I already said it's a rotation, but it's a rotation of what? Of how many degrees?
90.
90. 90 degrees about the origin. Okay, so let's do the ordered pairs for A, B, and C. What is A?
6, 2,
6, 2. B? 5, 4.
3, 2.
C is 3, 2.
No, 2, 3.
Thank you.
God, Corey.
All right, what about A prime?
It's 2, 6.
No,
Negative
it's
2, 6.
Negative 2, 6. Okay, B prime?
Negative 4, 5.
Negative 4, 5. And C prime?
Negative 3, 2.
Negative 3, 2. Okay, so I already heard it. What rule? We're going to switch the X and Y's. And do what?
Negative 1.
And negate the Y.
Negate.
So, switch the X and Y, negate the Y. So my rule is negative Y, comma, X. Switch them and negate the Y.
There's a rotation about that.
That is a rotation of 90 degrees.
About 90 degrees.
Now, in a math class, your rotations are always counterclockwise unless otherwise stated. So you could put CCW here if you wanted to for counterclockwise. But if you ever intend to say clockwise, then you have to say clockwise.
Isn't it
Because
going?
in mathematics, rotations are always counterclockwise.
Isn't it going clockwise in this one?
No.
Okay.
Going this way.
No, it's not. Look at the original and look at the prime.
Oh, I'm looking at prime to original.
Okay. So, example 7. Take a look at this one. How can I rotate this from here to here? From here to here. The rotation of 180. Good. So, rotation of 180 about the origin. Okay, we already have AC here. It says to write them again. I'm okay not writing them again. It didn't move. It's in the same spot. So let's just do A prime, B prime, C prime. What is A prime?
-6, -2.
-6, -2. What is B prime?
-5, -4.
And C prime.
-2, -3.
Okay, so Brian already said
You
all you
negate.
do is negate both. Negate the X and the Y. So -X, -Y. And that gives us a rotation of 180 degrees about the origin.
And guess we have to remember all these.
It's not that hard.
Oh, I get it.
Excellent. Excellent. All right, you try number 8 on your own.
That's 270 degrees.
Indeed.
Congratulations.
All right, when you're ready, check it.
How do you know when you switch that?
Well, this was one of those where you just had to look at it. On this one, A was 6, 2. On this one, A is 2, negative 6. So they switch.
Gosh dang. What is that here? What kind of stuff is that? I don't know, maybe I'll cheese. They look kind of hard.
I gave up.
Now that reminds me of
Did he have a binder?
Alright, last transformation is a dilation. Alright, and unless otherwise stated, our dilation is going to be through the origin.
Okay.
Through origin unless otherwise stated. Okay, so a dilation of a point in a coordinate plane can be found by multiplying the x and the y coordinates by the same number. And that number is called a scale factor. So our rule looks like this.
Oh, I knew that.
xy yields n times x or n times y. And I've also seen k used. It doesn't matter. What it means is some number, some constant is multiplied times both your x and y. And that is called your scale factor. So what is the image of the point 2, 3 when it's been transformed by that dilation 4x, 4y? So what happened to both my x and y? 8 and 12. Okay, and what is our scale factor?
4.
4. That's what we multiply by.
Wait,
Okay.
what? Oh, okay, sorry.
Alright, we have a new picture for this dilation, and they asked us to use a scale factor of 1.5. So first, let's look at all of our coordinates. A is 2, 0. B is 0, negative 2. C is the point negative 2, 1. And D is the point 1, 2. Now, with a scale factor of 1.5, what we have to do is go back and multiply each x and each y by 1.5. So to get A prime, it would be 3, 0. B prime would be 0, negative 3. Whoop, prime, don't you forget your primes. C prime would be negative 3, 1.5. D prime would be 1.5, 3. So all I did was go back through each one of these x's and y's and multiply it by 1.5. Make sense?
Easy.
Good. All right, then we plot those points. So here's A prime. Here's each one of them. We just plot, and then we connect the dots. And you definitely would use a straight edge. I didn't do it on that one. Okay, so there's the image after a dilation of a scale factor of 1.5 through the origin. All right, I tricked myself on my number B, letter B. So let's see if y'all get tricked or if you're good. Okay, if you're given the pre-image and an image point, corresponding image point, how do you find the scale factor? What do you think we do?
Divide the prime.
That's 1.5.
Yeah, take the prime and divide by the pre-image. The image divided by the pre-image. So this is 1.5.
The other one is 0.5.
Oh, you got tricked too.
It's 2.
No, I
had it
didn't.
like
It's
that.
2.
It's 2 because look what I did. I did
Yeah.
image and then
I don't like
pre-image.
that.
I messed my own key up.
Aha.
It's really good.
I did. Okay. And then what would this one be?
4.
0.25. 1/4 or 0.25?
Just going back.
See, Miss Willoughby?
You take the
Good.
image.
You did well today.
Or you,
Alright.
take the, you take the pre-image and divide it by the image.
Image divided by pre-image.
Just the same thing. I've never learned this stuff.